Hey class, it's Professor Lair. Today we're working on two equations and two unknowns, or another form of linear systems. So they give us this in this particular problem here in section 9.1 of the alternate textbook. I gave you a link in today's announcement on 10/9, October 9th, as to this section in the book. And I've got just a little bit different page number in this physical textbook, but I gave you section 9.1, systems of equations of two variables. So here we have two equations, x minus y equals 5 and x plus y equals 1. And these are linear equations because both x and y are only of the first degree, right? There's no squared term here. So these are linear equations, and then we could obviously put them in y equal mx plus b form. So when you plot these, when you have two lines, we have a couple options. Lines are either parallel and they'll never intersect, or two lines will intersect in exactly one point. Okay, so this is by far the most common situation. We have two lines. It doesn't matter what their slopes are. They're going to intersect in one and only one point, because this will keep going up toward infinity this way, that one will keep going up toward infinity, but eventually they'll hit. And even if they're two not quite, they're merging lines, eventually they're going to come to a point of intersection and then go their own way forevermore. So they will always intersect unless they're parallel or they're the same line, and in which case they're always intersecting, so you have an infinite number of points. So they call this independent or dependent. And then we've got this situation here. This is the most common. So we can either solve it graphically and plot your points and find the location of intersection, or we can solve it numerically by what's called there's two methods, the substitution method, and we've got the elimination method. So we are going to focus first on the substitution method. So we have these same two equations, x minus y equals 5 and 2x plus y equals 1. Right, and these equations over here, x minus y equals 5 and 2x plus y equals 1. All right, so I'm going to just do it for you, and then you can also read through the book. So we got x minus y equals 5, and we've got 2x plus y equals 1. So what we're trying to do is put an equation in terms of one variable. So right now, the easiest way to do this is to bring, say, x is equal to, bring the y to the other side, right? What do we have to do? We have to add y to both sides. So this is equal to 5 plus y. So now I know x equals 5 plus y. Or I could, well, anyway, let's just start with it. It doesn't matter how you do this. It doesn't matter which variable you pick. It does not matter which equation you pick. What we're trying to do is isolate one variable, one unknown, and put it in terms of the other variable. Now, wherever x is in the other equation, plug in 5 plus y. So here we have, this equation, 2 times x plus y equals 1. But x equals 5 plus y. So I'm going to put in that 5 plus y right there. Right? That's what this term is, right? Substitution method. I'm going to substitute one variable. Right? I isolate it and then I substitute that value into the other equation. Okay, what was the other equation? So it's 2 times 5 plus y, right? So x is 5 plus y. And we're looking for that place where these two are the same. So these two, we're kind of setting these equations, we're tying these two equations together by doing the substitution method. Okay, so we plugged in the x is 5 plus y, 2 times that quantity, 5 plus y equals 1. Now we have an equation that we can solve. There's one equation with one unknown y. Carry out the 2 times each quantity, so we have 2 times 5 is 10, 2 times y is plus 2y, plus y equals 1. Now we collect our terms, so we have 3y plus 10, but we don't want the 10 over here, we want the y by itself. So let's subtract 10 from both sides. 3y equals 1 minus 10. All right, I've just kind of done 2 steps at once. The 2y plus y is 3y, and I don't want this 10 over here, so I have to subtract it from both sides. So minus 10 gives me a 0 over here, and 1 minus 10. So we have 3y equals, what is 1 minus 10? Negative 9. Divide both sides by 3. Right, so I divide both sides by 3 or multiply by 1/3. Right, we can multiply by 1/3 or just divide both sides by 3. Right, the 3's cancel out. I have y equals negative 9 divided by 3 is negative 3. Okay, so now we know y equals negative 3, and now we can plug that back in. If we know y equals negative 3, now we have one equation with one unknown. So let's plug that back in. We got x equals 5 plus y, but we just determined y equals minus 3. So we have 5 plus a minus 3. So x is equal to 5 plus minus 3, which is positive 2. And now we have the point 2, negative 3 is the point of intersection, and it will satisfy both equations. Okay, by substituting this into this one, we force these two equations to be equal, and then we've isolated that point where they are equal, which is going to be the point 2, negative 3 satisfies both equations, and thus is the point of intersection. So let's just try it. Right, we got x minus y equals 5. What is x? X is 2. 2 minus a minus 3 equals 5. Okay, so it satisfies that equation. And then 2x plus y equals 1 is the other equation. Plug that in. 2 times x, that's 2 times 2, plus y plus a negative 3 equals positive 1. So 4 plus a negative 3 equals 1, 4 minus 3 equals 1, 1 equals 1, boom. So that point 2, negative 3 satisfies both equations and is thus the point of intersection. So we found a point, it exists, and that is that point of intersection. So anytime you have two equations and two unknowns, you can use this method. All right, let's just do one more quick problem from the textbook. All right, so it says use the substitution method. So you're going to do these problems here. I think it was like 17, whatever it was. It's in the homework. Some of these problems here, the odd ones, I'll do a quick even one. Remember, the odd ones are in the back of the book, so you can look it up. We'll do one with fractions in it here. So we got 3x minus y equals 5, and then I have x plus y equals 1/2. And here's the solution right here in the solutions manual. Okay, substitution. So what we're trying to do is look for an easy way to plug one in the other one. In this case, we could bring the minus y to the other side and have 3x minus 5 equals y, or we could just bring the y to the other side, or the x to the other side. So again, it doesn't matter which variable we're isolating. We just want to put it in terms of x equals something or y equals something, so we can substitute that into the other equation. So let's do this one. So let's say this time we'll do x equals 1/2 minus y. Right? We got a variable isolated, and now we're going to plug this in for x in the other equation. So that's tying the two equations together. So over here we have 3 times x. Well, x is this quantity 1/2 minus y. 3 times x, 3 times 1/2 minus y. minus y equals 5. Okay, 3 times 1/2 is what, 3 halves? Minus 3y minus y equals 5. So we have 3 halves minus 4y equals 5. I got to get the negative over here and this over here, so I'm just going to add 4y to both sides and subtract minus 5 from both sides. All right, so I have 3 halves minus 5 equals 4y. I brought this to the other side, which means I added 4 to both sides, so now it's over here, it added 4. And I brought the 5 over to the other side because I can get all my constants together. There's no variable here, these are called constants. Okay, and it's positive 5 over here, so I have to subtract it over here, that gives me the negative. I add 4y to both sides. Now I gotta get this y by itself. Might be easiest to deal with this before we have to deal with the 4. So what is 3 halves minus 5? 3 halves, I'm going to get these in equivalent terms, right? So I'm just going to multiply this by 2 over 2 to make this a 2 on the bottom. So this is minus 10 halves equals 4y. So 3 minus 10 is minus 7 halves equals 4y. Divide both sides by 4 or multiply both sides by 1/4. Might be easier to think of this one as multiply both sides by 1/4. When you multiply, the denominators, I'm sorry, the numerators are multiplied by each other. 1 times 7 is negative 7. 4 times 2 is 8. 4 times 4, that cancels out, right? That's that reciprocal. So that just multiplies, just makes it 1. So I have y equals 7/8, negative 7/8. Okay, so we have y. Let's come up here and figure out what x is. So y equals negative 7/8, so plug that in right there. Right, so now this kind of comes up, and we're going to plug in that negative 7/8 right there. So x equals 1/2 minus 7/8. Right, because there was a minus 7/8 down here. There's a minus here, so minus minus. We're just plugging that in. Now we need to get this also into like terms to actually be able to do this. This is going to become plus over here, but these are 8s, so I need to multiply this by 4 over 4 to get this in fractional terms. So x equals 4/8 minus minus means plus 7/8. So x equals, right, we can combine this to be 4 plus 7 divided by 8 because they have the same denominator, which equals 11/8, which was hopefully that was our answer. X equals 11/8 and y equals negative 7/8. And that would be the point of intersection of these two lines. 11/8 and minus 7/8. And then you can plug these back in and check to make sure they work for both. So we have 3 times x minus y equals 5. So the x value is 11/8. So I have 3 times 11/8 minus y. Minus y is minus 7/8 equals 5. Okay, so that's 3 times 11 is 33 over 8. 33 over 8. Minus minus means plus. Plus 7/8 is 5. 33 plus 7 is 40 over 8 equals 5. 5 times 8 is 40, right? 40 divided by 8 is 5, so 5 equals 5. So we're good. So it satisfies the first equation. That point of intersection satisfied this one. And it has to. It's a point on the line, so that means it satisfied it. And it was also a point that we found in common by tying the two equations. We tied the two equations by substitution. We solved one variable in terms of the other, plugged it in, found the value of y that was associated with this problem, and then we plugged it back in and found x. And we could plug it back into either one. We just typically solve in terms of one and then plug it back in the other. But it doesn't matter which. it's going to work. And then x plus y equals 1/2. X plus y equals 1/2. So x is 11/8 plus 7 plus a negative 7/8 equals 1/2. Well, that means 11 minus 7. 11 minus 7 is 4. 4/8 equals 1/2. Reduce our fraction, 1/2 equals 1/2, and we're good. That is the substitution method, and this was problem number 18, and then we worked out example 1. I'm going to move on to the elimination method in another video.